This is a digital SAT math question that has to do with equations. Hopefully you recognize this. If you don't, you should look at your parent equations. This is an exponential equation. I'm going to show two ways to find the answer, one mathematically with maybe a shortcut compared to what other people would do, and then also we'll use Desmos, bro. In the function f of x above, a times b to the x over n, a, b, and n are integer constants. If f of 4 equals 4 and f of 7 is 108, then what is the value of f of 9? Well, let me try plugging these things in. I'll try to, now there's three unknowns, a, b, and n, and only two here. So how am I going to use two equations to find three unknowns? Well, hopefully something's going to work out. I'll put in 4 for x, and then the whole function will equal 4. So 4, well, it will equal 4. And then it's a times b, x is 4 over n. Okay, now the second equation, when x is 7, the function equals 108. So a times b, 7 over n, b to the 7 over n equals 108. Now this is something that you sometimes do for simplifying. Try to divide equations. I'm going to divide this one by this one, the bottom by the top, and both sides. So a times b to the 7 over n divided by a times b to the 4 over n equals 108 divided by 4. And if you do that on a calculator, you will find that that's 27. The a's cancel out. I've got b on the top and the bottom, and it's to two different powers. So I can just, when I have the same base, and it's being divided, and each one is to a power, I can subtract the exponent. So this is b to the 7 over n minus 4 over n, and that's going to equal, what's 7 over n minus 4 over n? 3 over n equals 27. Now you can do something different, or you can look at this. Whenever I'm dealing with exponents and bases, I try to get the bases to be the same thing. Well, I see this 3 up here. Is something to the third power 27? Yes, 3 to the third power. So I'm going to write b to the 3 over n equals 3 to the third power. And I can rewrite 3 is 3 over 1. Well, check it out now. b is 3, b equals 3, and n equals 1. So I've got two of my unknowns. b is 3 and n is 1. I will plug it into one of the equations and see if I can solve for a, and I'll use this one. A times 3, and then x is 4 over 1 power equals 4. Well, let's see. 3 to the 4th power is 3 times 3 is 9, 27, 81. 81a equals 4. I'll divide both sides by 81. a equals 4 over 81. And I cannot simplify that. So now I will put with x equal 9. I've got a, b, and n, so x equals 9. 4 over 81 times 3 to the 9 over 1 power equals what? Well, I can put that into Desmos now. That's why I have Desmos. Let me get rid of this. This is for the next step. I will put 4 over 81 times 3 to the 9th power, and that equals 972. Okay, there's the math way. And I had to explain things along the way. I think you can do that within a minute. Excuse me. But here's another way to do it. I'm going to put the values I know. This is Desmos. It says when x is 4, the function is 4. When x is 7, the function is 108. Now I press this button with the line and the dots on either side, gives me a regression. I know it's an exponential function. You have to know that. And then I can actually get it to write the function. And instead of y, I'm going to make it f of x. So now I can put any x value, f of 9, let's say. And it comes out to 971.9996841. 971 971.9. Remember, on digital SAT, you can put five digits, including a decimal or the fraction. So 1, 2, 3, 4, 5. So that would be an answer that would be accepted. Or I can round it. And what happens if I round this? 9 because it's 0.99. I'm rounding it. This 9 becomes a 10. 2, so it's rounded is 972. So I can either write 972 or 971.9. Both of them would be accepted. But it's the same answer with Desmos. I think the Desmos is a lot quicker.